Hey everyone, welcome back. I hope everyone had a good holiday break. Today we are going to pick up kind of where we left off. We're pretty much going to review the remote work from last week. And instead of me going through a PowerPoint, we're just going to read the chapter together. By the end of this video lecture, you should understand how water moves through the atmosphere and what relative humidity is and how it's measured. All right, let's get started with the chapter. All right, so how does water move through the atmosphere? During a rainstorm, the air feels moist. On a clear, cloudless day, the air may feel dry. As the sun heats the land and oceans, the sun provides energy to change the amount of water in the atmosphere. Water is always moving between Earth's atmosphere and surface. The movement of water through Earth's systems, powered by the sun's energy, is the water cycle. So it's key to remember that the sun is driving all of these processes. In the water cycle, water vapor enters the atmosphere via evaporation from the oceans and other bodies of water and leaves by condensation. Evaporation is the process by which molecules of liquid water escape into the air after becoming water vapor. Condensation is the process by which water vapor becomes liquid water. So the sun heats up water on Earth, it evaporates, it gets so hot that it becomes water vapor and evaporates. As it rises, because once again, when air expands and gets warmer, it rises, becomes less dense and rises into the atmosphere. As you get up higher in the atmosphere, that water vapor cools down. When water vapor cools down, it condenses back into its liquid form. All right, so before we continue on with the reading, I do want to point out the vocabulary up here. The vocab for this lesson is water cycle, evaporation, condensation, humidity, relative humidity, and psychrometer. You will, after this video, I am going to have you do a vocabulary assignment. So just a heads up on that. But let's continue with the reading. All right, so water vapor is also added to the air by living things. Water enters the roots of plants, rises into the leaves, and is released into the air as water vapor. Animals also release water vapor into the air every time they exhale. So when we're exhaling, it's not just carbon dioxide and other gases that are coming out, it's also a fair amount of water vapor as well. As part of the water cycle shown in Figure 1, some of the water vapor in the atmosphere condenses to form clouds. Rain and snow fall from the clouds towards the surface as precipitation. The water then runs off the surface or moves through the ground back into lakes, streams, and eventually the oceans. Then the water cycle starts all over again with evaporation. So let's take a look at Figure 1. Let's start with, and I want to use a color that's going to show up well on this, so I'll use yellow. Let's start off with this bottom left rectangle here. So what word from the word bank do you think needs to go here? I'm going to give you guys a few seconds, come up with an answer, and you're going to answer within this Edpuzzle. All right, so that bottom left rectangle, that is the start of the water cycle. The process that starts the water cycle is evaporation. So I don't have my tablet with me, so I'm just going to write E for evaporation. Let's move on to the next rectangle up here. After water evaporates, it rises up into the air and does what? It's either condensation or precipitation. Take a second, figure it out, and answer the question. All right, if you said condensation, you are correct. So remember, water turns into water vapor via evaporation. As it gets higher up into the atmosphere, the temperature of the water vapor cools off, and then it returns into a liquid form. That's called condensation, and then it forms clouds. After it forms clouds, when clouds become heavy and more saturated with water, that water has to go somewhere. So what happens is the water falls back down to the earth via precipitation. All right, last but not least, let's talk about humidity. So what is relative humidity and how is it measured? How is the quantity of water vapor in the atmosphere measured? Humidity is a measure of the amount of water vapor in the air, and it's probably a word that you guys have heard, throughout your whole lives. The ability of air to hold water vapor depends on its temperature. Warm air can hold more water vapor than cool air. Weather reports usually refer to water vapor in the air as relative humidity. Relative humidity is the percentage of water vapor that is actually in the air compared to the maximum amount of water vapor the air can hold at a particular temperature. For example, at 10 degrees Celsius, 1 cubic meter of air can hold at most 8 grams of water vapor. If there is 8 grams of water vapor in the air, then the relative humidity of that air would be 100%. Air with a relative humidity of 100% is said to be saturated. If that same 1 cubic meter of air only had 4 grams of water vapor at that 10 degrees Celsius temperature, the relative humidity would be 50% because it's holding half the amount of water that air can actually hold. So, how is relative humidity measured? Relative humidity can be measured with an instrument called a psychrometer. A psychrometer has two thermometers, a wet bulb thermometer and a dry bulb thermometer. As shown in figure 2, the wet bulb, I'm going to scroll down so you can see figure 2 a little bit better. The wet bulb is covered by a moist cloth. When the psychrometer is slung or spun, air blows over both thermometers. Because the wet bulb thermometer is cooled by evaporation, its reading drops. If the relative humidity is high, the water in the wet bulb evaporates slowly. If there's more water in the air, the cloth is not going to become less moist. Uh, the wet bulb temperature does not change much. If the relative humidity is low, the water on the wet bulb evaporates rapidly, and the wet bulb temperature drops by a large amount. The relative humidity can be found by comparing the temperatures of the wet bulb and the dry bulb thermometers. And we'll do, some more hands-on questions in class regarding relative humidity. All right, so that's it for today's video lecture. So make sure you answer all the questions in this video, and now you have a vocab assignment to do, and that will pretty much finish up your remote work for this week. So as always, if you have any questions, shoot me an email, and I look forward to seeing you guys in class.